Hello, it's David from David's Electrical Services Ltd, and today I have something rather exciting to show you all, the SY2-D Surge Protective Device. But first, my thanks to Paul at NIC for sending me this rather spiffing t-shirt and hat combo after taking pity on me in my last video where I was out at the weekend in a t-shirt from Elex. Now I have some alternative weekend wear when my uniform is in the wash. Paul has obviously spotted me for being the freebie whore that I am, but who doesn't like a surprise gift turning up in the post? But you didn't tune in today to see my ugly mug, did you, viewers?
Piss off!
No, indeed. Okay. Well, here is the star of the show, the SY2-D, and this is what we're going to be playing with today. This particular unit has been kindly supplied to me by the good folks at Surge Protection Devices Ltd. I was at the Elex show in Coventry last week, and this is where I came across the stand for Surge Protection Devices Ltd, who, I must admit, are a brand I'm not personally familiar with. Their representative on the stand certainly knew her products and was doing an impressive job of fending off questions from several directions at once from people like me who traditionally haven't had a lot of exposure to surge protection devices and don't know much about them. I found this SPD product in particular to be rather exciting, so I went off with her brochure intending to find out more, and indeed I wasted no time by popping into City Electrical Factors that very afternoon, who shrugged their shoulders at the mere mention of SPDs. Then I went into Edmondson, who did exactly the same. Denmans, however, do list a surge protective device, model SS40, and badged for use with their curve and steeple boards, but I'm pretty sure I've also seen it with Luden branding, which is no surprise as I think these all come off the same production line, although I may be wrong. Anyway, the Denmans website shows no stock of the SS40, so these are either selling like hotcakes or they're not shifting in any quantity at all, and I suspect the latter, to be honest. The general lack of availability and product awareness at the sales counter tells me that these large suppliers aren't selling a lot of SPDs at this time. I guess most jobbing sparkies, especially those who mainly work domestically, are not routinely installing SPDs, which is no real surprise as 17th edition and earlier didn't cover the topic too much. Off-the-shelf consumer units, whether empty or fully loaded, are supplied without an SPD and often with little consideration for the retrofit of such. And in the competitive market of domestic installations where dickhead chancers, cowboys, unqualified builders and such are spunking consumer units onto the walls with little or no regard for the wiring regulations and at a price that undercuts legitimate installers, well, it's hard to justify adding in extra part costs unless the client has expressly requested such additional functionality. Which they generally don't when it comes to SPDs, as Jill and Joe Schmo out on the street probably have no idea these devices even exist. Besides, I suspect there are relatively few damaging surge events here in the UK, or at least I've not been called out to deal with many in my time. So why are we talking about this now? Well, because of 18th edition, of course. 18th edition doesn't just introduce us to the arc fault detection device I played with in a previous video, it also beefs up the requirement for installing SPDs. When I did my 18th edition video back in July, I skipped over surge protection as I hadn't had time to take it in. Well, I've had a closer look now and I'm in a better position to explain what it means for most jobbing sparkies. But before we begin, it's important to understand that there are three different kinds of SPD. Type 1 would be located at the main incoming position and protects against a direct lightning strike. Type 2 would be at the distribution board and protects against indirect lightning strikes. Type 3 would be fitted to a final circuit or at an item of equipment to protect locally against switching over voltages. That's the kind of overvoltage that may be caused by large inductive loads, such as motors and air conditioning. Combination units can be sourced, and according to the manufacturing blurb supplied with my model, a Type 2 SPD is OK for installations fed by underground cables, but a Type 1-2-3 combination device would be required for installations fed by overhead power lines, regardless of whether that's single or three-phase. I'll be playing with a Type 2 device here today as I'm on an underground PME connection, so this is what I'll be installing here. Incidentally, this device is suitable for both TN and TT installations. 18th edition Regulation 443 is what we're interested in, and in its own roundabout way it says that if you're covering an installation from surges caused by atmospheric conditions, then you'll likely also be covering it against switching over voltages which are normally lower in amplitude. This means that by installing this device into my consumer unit I should be protecting my own installation adequately enough for whatever me, the bloody wife or Mother Nature can throw at it. But as 18th edition bites in, am I actually required to be installing these things for my clients as a matter of course? Well, let's quickly look into that before we get the screwdrivers out. Regulation 443.4 states, Protection against transient overvoltages shall be provided where the consequence caused by overvoltage could result in serious injury to or loss of human life, or result in interruption of public services and or damage to cultural heritage, or result in interruption of commercial or industrial activity, or affect a large number of co-located individuals. For all other cases, a risk assessment according to Regulation 443.5 shall be performed. So, if you want to get out of installing SPDs, you turn to Regulation 443.5, which gives you a formula for calculating the risk level. If the result is greater than or equal to 1,000, then you don't need surge protection, but if it's under 1,000, then you do. Ready for this? Let's see if we can calculate the risk for my own dwelling. Here's the formula. Calculated risk level equals FENV divided by LP times NG, where FENV is an environmental factor selected according to Table 443.1. LP is the risk assessment length in kilometres, and NG is the lightning ground flash density measured in flashes per square kilometre per year relevant to the location of the power line and connected structure. Okay, as far as mathematical formulas go, this doesn't look too terrible. We just have three factors to find. Let's start with FENV and refer to Table 443.1, which seems simple enough in that there are only two numbers to consider. I'm not sure at which point you differentiate between urban and suburban installations, but for my house I'm going to go for rural and suburban, seeing as I'm on the outskirts of a market town with a golf course and green fields immediately behind me. So my value for FENV is going to be 85. God only knows where they get 85 and 850 from, but I'll swallow it for now. So far so good. Let's skip then to NG, the lightning ground flash density. We can find that on page 102 of the Big Blue Book. This map shows us the lightning flashes per square kilometre, and as you'd expect, the southeast has a higher density of lightning strikes than up to north, as indicated by the darker areas of the map. It varies from a factor of 0.1 for areas with a low volume of thunderstorm activity up to 1.4 in some parts of Suffolk and Lincolnshire. Where I am here in Warwickshire, I can see that NG is a factor of 0.8. Lovely stuff. All I need now is LP. Let's see, LP, the risk assessment length LP is calculated as follows. LP equals 2 LPAL plus LPCL plus 0.4 LPAH plus 0.2 LPCH, where LPAL is the length of low voltage overhead line, LPCL is the length of low voltage underground cable, LPAH is the length of high voltage overhead line, and LPCH is the length of high voltage underground cable. Ah, Christ, I knew this was looking too easy. Well done, lads, well done. You've managed to go and pull my pants down in my moment of complacency. Okay, well, let's define what these damn things are. Here's a picture of my house. Obviously, as an electrician, I'm stinking rich, at least according to the fake news specialist, the Daily Mail, who reckon I'm on £3 per week, so yeah, it's a pretty big gaff. Incidentally, if any fellow electricians can recommend a good ramparts cleaner in my area, then I'd be keen to hear from you. One does so tire of scrubbing the lichen from one's own battlements, but I digress. So let's start with LPCL, as that's the bit that's connected to my house. Indeed, it's the length of the low voltage underground cable between my intake position and the nearest LV transformer, illustrated here as being pole mounted. Although that may not be the case, of course. Now we have LPAL, which is the length of the low voltage overhead line. Then we have some more to factor into LPCL, where the cable runs between the high and low voltage transformers. LPCH is the length of high voltage underground cable, and LPAH is the length of high voltage overhead line. Now, different installations will be fed in differing ways. It's not always going to look like this, but yeah, to perform this calculation I need to know these distances. Unless you're a developer building a new estate where these factors are known because you're involved in them physically being trenched in on your watch, then you're not going to be plugging any numbers into this formula with any kind of accuracy. Regulation 443.5 says that where the distribution network lengths are totally or partially unknown, then LPAL can be assumed to be the difference between LPCL and 1 kilometre. So if the underground cable to my house is 100 metres long, LPAL can be assumed to be 900 metres long. What a load of old balls. I don't know how long my underground cable is. I'm not even sure which transformer I connect back to on this estate. I have measured an external impedance of 0.08 ohm here, which may indicate a length of between 35 and 55 metres, depending on whether my incoming cable has a CSA of 16 or 25mm to my 60 amp PME head, but really I'm pissing in the dark here. I'm not aware of a transformer that close to my property, but there are some buildings on the golf course which might house such. I don't know, I'm not a member, so I've got no access there. Wii Golf is as close as I ever got to pulling on a pair of tartan +4s and a bloody beret with a bobble on the top. I did try the real thing once and I found I can knock chunks of grass out of the earth with the best of them, but whopping that silly dimpled ball any kind of meaningful distance certainly never happened. Where was I? Sorry, I seem to have drifted off topic. Ah, yes, this formula. So it's damn near useless for most of us norms, unless I'm missing something. I mean, I might be. I'm just a street asshole trying to get my head around this new 18th edition stuff just like you. I did call the NIC-EIC technical helpline, but they also weren't too familiar with how to deal with this particular calculation. Okay then. For shits and giggles, let's go with a figure of 55 metres for my underground cable and for the value of LPCL, just to try this formula out. This means I can apparently assume LPAL is 945 metres. I already don't like this. Assuming numbers for a formula seems to defeat the purpose of doing any maths. I may as well just make up the results, as I've no confidence in whatever the answer will be. Anyway, we'll keep flogging this dead donkey and see where it goes. As I only have numbers for LPAL and LPCL, I'm disregarding LPAH and LPCH. That's what they seem to do in a few worked examples in the blue book, so anyway, as the formula works in kilometres and we have values in metres, we'll shuffle the decimal points around. So take 0.945, multiply by 2 and add to 0.055, which gives us 1.945 as a value for LP. Okay, let's plumb all that into our original formula for the calculated risk assessment. 85 divided by the product of 1.945 multiplied by 0.8, will it be higher or lower than 1000? Well, obviously it's lower, and it seems to me like it pretty much always will be, unless you're living in deepest Scotland with a friggin' supply transformer located right next door to your haggis pantry or your bagpipe store or the kilt shed, if there are such things. I don't know, I've only ever got as far as Motherwell before thinking, to hell with this, and pointing the car's bonnet back in a southerly direction, so I don't know what deepest Scotland is like. But anyway, if you don't know the cabling distances to accurately use this formula to get out of installing surge protection, then to comply with 18th edition you're going to be fitting SPDs as a matter of course in commercial installations. Why commercial installations? Well, there is a silver lining for domestic applications. Going back to Regulation 443.4, a get-out clause is given for single dwelling units where the total value of the installation and equipment therein does not justify such protection. So you can sidestep surge protection when working on a single house, flat, apartment, etc. Nonetheless, you should really discuss with the homeowner the benefit of forking out for the installation of surge protection and have them make that decision. An elderly couple, for example, with few high-end electrical appliances in an urban location and at a low risk of a lightning strike, may feel it's just not worth the expense, whereas a gadget freak in a rural environment may feel more inclined to shell out a bit extra to see their installation and appliances suitably protected. And today I'm looking at the practicalities and costs for providing that protection, at least on a single-phase dwelling. So enough with the friggin' maths, let's have a look at the SY2-D and how to install it. Unlike arc fault detection we were playing with in a previous video, which is applied to individual circuits, a Type 1 or Type 2 surge protector is connected in parallel with the entire installation, meaning only one needs to be fitted. In the case of this Type 2 model, it's the size of a standard MCB and so can sit on a DIN rail at the CU. However, notice that the bottom terminal is for protective earth. This model does not sit on the buzz bar, so in retrofit applications the buzz bar may need to be cut down. As shown here in my somewhat perspectively challenged picture, knocked out after one whiskey too many I fear, the protective earth terminal is shown connecting to the MET in the consumer unit while the line connects to a 16 to 32 amp breaker. That breaker can be one dedicated to the task, or if space is sparse, perhaps use one that also serves another circuit. Obviously neutral connects to the neutral bar associated with any RCD the breaker is hanging off. It's earth leakage free, so shouldn't trouble any RCDs located upstream, at least not in the case of this particular Type 2 model, although Type 1 SPDs are a different kettle of fish according to the Blue On-Site Guide. Regulation 534.4.7 requires any upstream RCD to have immunity to surge currents of at least 3 kA, but devices compliant with BS-EN 61008 and 61009 do satisfy this requirement. Effectively, this SPD is treated as a final circuit in its own right. If there's no space in the existing CU to accommodate it, then it can be installed in another enclosure adjacent to the CU. Regulation 534.4.10 requires a Type 2 SPD to have an earthing conductor with a CSA of 6mm², and for its supply conductors to be appropriately rated for the breaker in use, but to be of a size of no less than 2.5mm. So you can use 2.5mm for a 16 or 20 amp MCB, maybe bob up to 4 or 6mm if hanging off a 32 amp, although I don't know if I'd bother. For a Type 1 SPD, minimum CSA is 16mm for the earth and 6mm for the supply conductors. When it comes to locating this device into a CU, we have to bear in mind new regulation 536.4.203, which disallows components to be installed in consumer units unless type tested by the manufacturer. So retrofitting one of these into an existing enclosure could fall foul of that. I'm told that the SY2-D has been type tested for Luden boards and for Cefco, the manufacturing arm of CEF. So presumably that means the likes of MCG, M2 and Proteus, but I'm not terribly sure. If in doubt, check with the manufacturer or install in a separate approved enclosure. Although personally I'd probably accept the risk and note it as a deviation on the certificate so long as it fits on the DIN rail and the enclosure seals back together with no deformity or modification required. When it comes to mixing components in a CU, it's often busbar misalignment you need to be wary of, but that's not a factor here as this device doesn't sit on the busbar. Anyway, that's up to you to decide, but if mounting in an enclosure externally to the consumer unit, then keep it close. Regulation 534.4.8 prefers you not to exceed 50cm on the supply wiring, and definitely not to exceed 1 metre. I'm installing this device into DB2 on my installation, which is a Elex board that's hanging off an RCD protected way from DB1, which itself is a dual RCD high integrity board. DB3 is on the high integrity or non-RCD fuse way from DB1, and that's because DB3 is for my electric vehicle charge point, which itself requires connection via a Type A RCD rather than a Type AC, to prevent nuisance tripping from any DC components introduced onto the AC waveform. As mentioned earlier, I'm on a 60 amp PME feed, so DB3 runs my 8.5 kilowatt electric shower via a contactor to ensure the car charge point won't operate if the shower is in use. That's just to keep my maximum demand down and prevent my puny 60 amp fuse from vaporising in a cloud of fishy smelling smoke. This SPD probably isn't type tested for my Elex board, but to hell with it, it's my installation and I'm prepared to live with the risk. I'm going to have to cut down the busbar to fit this in, but there's a spare 16 amp breaker here which can drive the thing, and once fitted it'll protect DB1, 2 and 3, so type tested or not, I'm going to sleep easier knowing my installation is surge protected. There we go, installation is as easy as that. I've got a 6mm protective earth there and 2.5mm on the line and neutral cabling. How do I know it works? Well, I don't. There's no way for me to reliably test it. In fact, I'll have to periodically visually check it to ensure the indicator windows still show it as being functional. Some models come with an audible alarm or with contacts to connect to such, but not this one. Incidentally, you also have to be careful when IR testing on an installation with one of these fitted, as you could end up balking it if you spike 500 volts DC from your tester down the line. You either need to disconnect it, avoid it, or set your tester at 250 volts DC before any probe poking takes place. When a surge occurs, the SY2-D is supposed to operate within 25 nanoseconds and self-reset afterwards. That is, unless the surge was so great that the arse has been totally blown out of the thing, in which case the visual indicator should show red to inform you a replacement module is required. The surge module can itself be removed from the connection housing and a replacement unit slotted back into place, which hopefully saves time out on site. When it comes to costs, you can order directly from surgedevices.co.uk, and at the time of recording, the list price is £64 plus VAT and shipping. Although shipping is a bit steep at £12.50 plus VAT for Parcel Force Express 24, unless you order 4 or more units, in which case I believe delivery is free. I understand trade prices are also available, and the company says that these products can be sourced through Eddie's, Rexall, CEF and Denman's. Although you may have to push your local account manager to physically stock the things, at least until they figure out that 18th edition means we mere punters actually need to get our hands and our screwdrivers onto these things. By sheer coincidence, as I was researching this video, I cleared up some of the paperwork piling up on my desk and I came across this autumn special offers flyer from Denman's, and look what I spotted inside. This SRG1 VCU item appears to be separated at birth from my SY2-D. And is branded as Luden. Surge Protection Devices Ltd did tell me that they branded for Luden, so there you go. It's a rebadge, presumably with the same internal gubbins, and by gubbins I mean a heavily insulated varistor, I guess. As of recording, this part code doesn't show up under a search on the new and improved Denman's website, but if you're after one of these, then SRG1VCU or code 1078393 should allow the counter bod at Denman's to source them for you. So here's the bottom line. If you're on a new commercial installation, chances are you'll be required to fit an SPD, especially if it's in a non-urban location. That is, unless you know the numbers for that daft risk formula and the calculation gets you out of it. If working domestically on a rewire, a new build single dwelling, or on a CU change, then offer it to your client, but it'll cost them about an extra £100 just for the parts by the time VAT and any shipping is added on. Is that a lot to fork out? Well, it depends on how many high-end appliances they have, how flush they are, and whether they live somewhere more prone to thunderstorm activity. A client's insurers may also require surge protection to be fitted, especially if a previous claim has been settled following damage to electrical equipment by a lightning strike. They may pay out once, but they won't again, as lightning does strike in the same place twice, and they'll want you to take measures to protect yourself from it. Prices will hopefully come down with economies of scale, and it may be the case that CU manufacturers themselves get on board and start including these devices alongside the main switch in their off-the-shelf enclosures. We'll see, I guess. In the meantime, devices such as the SY2-D make the business of surge protection less onerous, as this in particular is a rather neat and low-cost solution. At the end of the day, justifying the cost for these things is the same as when people ask me if it's worth them fitting, wired interlinked smoke alarms or RCDs. It's worth that cost if the one time you need them, they are there. Better to have and not need than need and not have. Is £100 really too much to ask when it comes to protecting your entire electrical installation from surges? I guarantee that if you say yes to that, then next summer when the lightning storms draw in on a humid day, you'll be in two minds as to whether that was the right call. Anyway, see you next time. Thanks for watching.